Hi guys, in science, a law doesn't mean the same thing that it does in everyday language. In everyday language, a law is a rule that if you break it, you're going to go to jail or get fined, right? A law in science is like a rule in that it's an observable fact about the universe that we've written down. So we could say, this is how the universe behaves, and we know that because we've observed it many times. So here's sort of an addition to the definition that I gave you on your sheet. A law is a statement or an equation. You might think an equation can't be a law, but an equation is really just a description using math of something you could have described in words. So for example, there's an equation that you may have heard of in math that goes like this. A squared plus b squared equals c squared. And it describes the relationship among the sides of a triangle, and it's called the Pythagorean theorem. And that equation really just says that one side of a triangle times itself plus another side of a triangle times itself equals the third side of the triangle times itself. In words, that's pretty bulky, but an equation simplifies it. So laws in science are often written in the forms of equations, and don't let that scare you. It's still a description of a pattern or an event in nature. The red bullet under the word law here says that laws are considered universally true. And what that means, of course, is that everywhere in the universe they're true. They're not just true like in Wyoming, but not true in France, or true here on Earth, but not true in Mars or in some other galaxy, right? And that's kind of common sense. And probably the most important thing I want to tell you about laws is they do not answer the question why. Science answers the question why with a different kind of statement. Science answers why questions with theories. So let me give you an example of a law that describes the universe. It predicts patterns or events in nature. And then I want to show you the theory that's intended to explain it. So I have on the right-hand side a law of nature called Hubble's law of cosmic expansion. Dun, dun, dun. So what is this law of cosmic expansion? Well, it says that we can observe quite clearly that the universe appears to be expanding, just like things that would be on the outside of a balloon, like if you took a balloon and you drew some stuff on it, as the balloon blows up, look what happens to the stuff that's drawn on the balloon. This is what we observe about our universe. We observe that if you look at two galaxies, right, and these swirly things are galaxies, this one and this one, and you compare how close together they were back in time to how close together they are now, they're further apart. And they get even further apart in the future. We can observe this. This is not something that we're like predicting or we think happens. We can see that every galaxy in the universe is moving away from every other galaxy in the universe, the same way that dots drawn on a balloon move away from each other as the balloon expands. And from this, we know that the universe is expanding. And by the universe, I mean the space that makes it up. You can think of space as being like the surface of a balloon. It's expanding the way a balloon expands. This is a law because it is a description of a pattern that we see in nature. Notice how the cosmic expansion theory does not try to explain why this happens. But we do have some theories about why this happens. And the theory about why this happens that is most widely accepted by scientists, you've probably heard of it, it's called the Big Bang. There's another theory that's not widely accepted by scientists, and that one is called steady state. Whoa, I just made my A look like a D. I apologize, I can't fix the letter A. I want to, but I can't. So the Big Bang theory competes with this other theory of why the universe is expanding. So your choices are pretty much either there was a Big Bang or there wasn't. The universe has been in the same state steadily since the beginning. So why do scientists say, nope, they don't believe this theory, they believe this theory? Well, because they look at the validity of the Big Bang theory. They examine the evidence, and the evidence has to do with observations. Just like with our Big black box theory, just like with our black box theories and our models that we did with our boxes, scientists have to infer from the observations of the universe what they think is going on, just like we have to infer what we think is going on inside of our box. So the Big Bang Theory does three things. It answers the question, why is the universe expanding? That's the whole point of theories, is that they answer questions of why. And it accounts for all the known observations of the universe. And there's a lot of them, and some of them are pretty complicated observations that for beginning students like you guys would be hard to explain. They're hard sometimes for me to understand because I don't even have enough science background. But I'll introduce you to a few of those observations in a second. And the other thing that the Big Bang Theory has done is that it has accurately predicted several observations that had not yet been seen back when the theory was first proposed. That's a big one. And I tried to get you guys to do that with your black boxes. Okay, don't panic, but here are some of the observations that the Big Bang Theory tries to explain. The first one we already talked about. Again, you don't have to read all of the stuff on this page. I'm just going to summarize for you what it says. The first one we already talked about, though. It's the fact that the universe seems to be expanding. That's the whole reason we came up with the Big Bang Theory, is we needed an explanation for why space is expanding. Explanation? At some point in the distant past, there was a bang that set all of this expansion in motion. Notice we don't say what we think caused the bang. The next observation is something called cosmic microwave background radiation. Sounds complicated, but basically radiation is a form of energy and microwaves are one type of wave energy that we'll study this year. So microwaves moving around through the universe have no apparent origin that we can think of except if there had been a huge bang way back about 14 billion years ago. That's the best explanation we have for where this background radiation that doesn't seem to come from anywhere in particular have come from. And there's really no explanation for that in the competing theory. The steady state theory can't explain where this background radiation came from. And that's one of the reasons why scientists stopped believing in the steady state theory. The third one is the fact that the universe is way more active in the distant past than it is currently. And you might be wondering, how do we know that? We can't go back in time. If we could go back in time, we could just witness the Big Bang. And that's true to a point. We actually know a lot about the universe and how it behaved way back in the distant past because light takes time to travel. It's just that it travels so fast you don't even notice it. It actually takes 8 minutes for light to reach us from the sun because the sun is so far away from us. But since the sun's been putting out energy for millions and millions of years, we weren't here when the sun's first rays started to form. So, we didn't notice that it took 8 minutes for the first light to reach us from the sun. But this fact means that when we look up at the night sky with our telescopes, a lot of what we're seeing is stuff that has happened way, way, way back in the past. Many of the stars that we look at, the light from them is just reaching us now, but they exploded, supernovaed, and died long before we ever even were born. So in a way, we can look back in the past when we look at when we look up at the current night sky, we're really seeing the ancient universe. So we know that it's much more active in the past than it is today, and that would be explained by the Big Bang Theory. Numbers 4 and 5, you really have to know a lot of science to even begin to understand, but they are also observations that we can make about our universe. The fact that light shifts as it moves through the universe, and the fact that certain atoms are more common than they seem like they should be if the universe had been going along doing the same thing at a steady pace for billions and billions of years, we wouldn't have the numbers and types of atoms that we have today. So All of this long explaining is me telling you why the Big Bang Theory is considered a good theory, a good valid theory that helps to explain the law of cosmic expansion. So to sum up, I want you to really focus on your definition of the law as compared to the definition of a theory. A theory is an explanation of observations. You can see that on the left. But a law is just a statement or an equation that reliably predicts patterns or events. Theories attempt to explain how or why something something happens, and laws are considered universally true but do not attempt to answer the question why. Theories are more complex than laws, and they contain several supported hypotheses, but laws usually are based on one well-supported hypothesis that states something will happen. The final thought I want to leave you with is that laws do not graduate to become theories when they're proven. A law, by its very nature, is already something we've proven because we can see it directly. We can say, oh, the universe is expanding because we can see it. We only call things laws that we can directly observe. Theories, however, attempt to explain the unobservable. So a theory can never become a law unless somehow technology advances to the point where you can open up a black box and just look inside. At which point you no longer need to theorize. You can just say, hey, look at the inside the box. I can see what's there. So that's it for theory and law. See you guys in class.